Today we will tackle an increasingly important topic in C# design. The question is, how do we save a union of types into a relational database using EF-Core? What we see here is a simple union type. You will be creating these all day long when union types finally arrive in C#15. This union type captures every possible state when approving a money transfer. A transfer can require no approval at all, or it can be waiting for the first approver. It can be partly approved by one person, fully approved by two, or rejected. Each case carries exactly the data it needs and nothing more. That is by-the-book use case for union types. The approval is a part of the money transfer model. That will make things more interesting when it comes to persisting with EF-Core, because the approval record will be stored alongside the containing transfer entity. Can you see the difficulties already? The transfer entity has its own ID and the IDs of accounts from which and to which the money goes. Ultimately, there comes the approval record, which we must persist along with other data. The hard question for this video is how? That inevitably brings us to the database context, and this is what it looks like right now. You should pay attention to the transfer entity configuration. That is where the dragons will live when we finish configuring everything. There is the setup for its key and account references, but the approval property is explicitly ignored. EF-Core alone has no idea how to handle a discriminated union or a union type. That is exactly the problem we are here to solve. The first tremendously important lesson is that you cannot treat a union type as an entity. There is a compile time error on this entity registration, so we better take a look at what the compiler said. The build says that a type 4i's approval must be a reference type in order to use it as type parameter. Now what does this mean? Here's the story. Union types are syntactic sugar in C#. The underlying type is a value type, but do not bang your head around it. It is a detail of the language specification. It is an implementation detail of the compiler, if you like, but not the implementation detail of your software. For you, as the one who writes code in C#, a union type is a union of several types, just as you declared it. Any instance of a union type is precisely one instance of one of those types and nothing more. Now that you understand union types, we move on to the obstacle ahead. EF-Core does not allow value types as entities. Full stop. We are back at square one, thinking how should we persist the union type instance. For one thing, we should immediately dismiss the possibility of putting it into its own table. A discriminated union or union type instance does not have an ID. It is not possible to assign it an entire row in the database because it acts like a value. Compare it to an integer. So far, that aligns well with previous issue I had, where I couldn't treat the union type as an entity. Entities get an ID and a table for themselves, values don't. The verdict is that a union type or a discriminated union, whichever we used, must go into the table of the containing entity. That is another hard rule. There's one interesting and promising alternative we could pursue. The 4i's approval doesn't necessarily have to be a proper union type. If that is the impediment to persistence, then we can make 4i's approval an abstract record and derive the other records from it as subclasses. This hierarchy lets us use all coding patterns as with the union type, plus it is a pattern EF-Core can actually work with. Keep in mind that I have just turned a union type into a discriminated union. Reference-typed objects in C# have a type header, which is different for every derived type. Therefore, the type header in C# is a proper discriminator for a discriminated union. That is a trick question. Anyway, EF-Core will have no issues to persist this structure in the database, including in the same table with the containing transfer. Setting that up is a big topic in its own right, and I will not pursue it further in this video. A separate video will demonstrate that technique. In this video, we are back to the union type declaration again. This is what I want to configure in EF Core, and the question is again, how? The key question is how shall we represent the approval in the transfer class? EF Core will keep ignoring this property because it is a value type. That much is clear. My plan is to accompany it with some property that can be configured as complex property in EF Core so that it groups all individual properties that can occur in any of the appearances of the 4i's approval. The plan is to introduce a companion record that will serve as a data model as opposed to the domain model we use in memory. I will show you how you can persist this record to represent the value of the union type using EF Core's native features. But before that, let me steal a moment of your time to remind you that this video and all other videos on this channel are free only thanks to the patrons, the people who sponsor this channel on Patreon. If you like what you have learned from this video and other videos I have published, then please consider joining the growing community of patrons on my Patreon page. By becoming a sponsor, you will get access to the source code of this video and all other videos on my channel, as well as some discounts I occasionally post on Patreon. Thank you very much for your support. Now let's get back to code. This record will hold all the individual scalar fields that EF Core needs to persist. The declaration is still empty, so let's start filling in the components. The first mandatory property is the discriminator. It will tell which concrete approval state is stored. Every other field in this record will be optional, present only when the corresponding state requires it. 3 optional fields follow. The approvers cover partly and fully approved confirmation steps, while rejector covers the case where the transfer was declined. The other 2 possible variants not required and pending would leave all 3 properties null. That is why all properties had to be nullable in the first place. Back at the transfer, it should be easy to set up the approvals now. Besides the official approval model, declare a private data model that will hold the flattened value suitable for persistence. This is the bridge between the rich domain model and the flat relational row that EF Core will actually store. The private data model we just added to the transfer class is exactly what will let us replace the ignored property and fill it with real persistence logic. I will therefore show you the EF Core configuration first, before we move back to completing the conversions between the domain model and the data model. The approval property stays ignored. What changes is that we map the private data model through complex property, using its string name to reach the backing field directly. EF Core will flatten all the scalar properties of that type into columns on the transfers table. I will quickly add a migration and you will see that everything will go smoothly in EF Core. This is the migration. There are 4 new columns in the transfers table, including the discriminator. That is exactly the shape we need to reconstruct the correct variant when reading back from the database. But the story does not end there. The data model instance will stay null, causing a failure when we try to persist the entity. We need something unique here. We need automatic conversion between the data model and the domain model above. We need a way to convert the domain model into its data representation when EF Core needs it for saving, as well as a way to convert the data back into the domain model and set the approvals property when EF Core loads the data. EF Core will use this private property, but the object will never keep it in memory. The rest of the application continues working exclusively with the domain model, just the way we want it to. The resolution is in the data model itself. Data is one half of the data model, the other half is extensions that will do the object conversion. In a way, we are doing object relational mapping manually. Conversion from the domain model is lengthy but straightforward. It simply calculates the discriminator and the nullable properties from current object. The important part is in how the discriminator values are determined. I have intentionally fixed the string literals. It would be a mistake to use the name of operator. Class names may change in code later, but their prior data will remain in the database. Changing a class name would make it unable to decode past data, so the hard-coded strings it will be. The reverse conversion is much simpler now that we know which concrete type to instantiate. Back at the transfer entity, two-way conversions compile fine, that is where EF core and the domain model meet, and I can assure you that everything will work smoothly at runtime. Are you ready for the demonstration? Here it is. The demonstration consists of two stages. In the first one, I will insert some data, and in the second stage, I will update them. I'm creating one transfer object with pending approval, then another one which is partly approved, then simply add both objects to the DB context and save changes. How hard can that be for EF Core to repackage and store into the table? The updated demo is much more interesting. First, it shows how you can query the data by explicitly accessing the data model form. That is how it goes, because data model is what exists in the database. But once you fetch the data from the database, you do everything else in terms of the domain model. That is how you would write code anyway. Data conversion into the union type has made this code possible. When the change is made to the domain object, I can rest assured that saving changes will trigger a new conversion into the data model, letting EF Core isolate changes that happened to the object model. What else could you wish for? I will run the application and you will see that everything has worked just as advertised. There are two transfers in the database. One has a pending approval, the other was approved by one employee, awaiting the second one. Then comes the update, which has isolated this partly approved transfer, adding the second employee to it. Just as I said, everything worked as advertised. And this is the crux of the solution. I have defined a value-typed union of 5 record types. Despite not being able to subject a value type to EF Core persistence, I was able to work around the limitation with an explicit data conversion. This is the class that glued it all together. It is a custom data model that accompanies the union type. Until the time EF Core supports union types as first-class concepts, this is the workaround I would suggest.